So far, we have modeled cyber attacks and looked at how system behaves under such attacks. In the part 3, we will learn about the insights on the model block, such as resource block, identifying virtual connections, the algorithm accuracy, and recommendation, and provide recommendations. VisualSim has a very powerful block known as Insight Engine, designed to provide the intelligence in the model by accumulating the data from different blocks used in the model. It takes a constraint file as an input. Let's look at the model. So in the model, we have used the Insight Engine, and it has 3 parameters: requirement file, result folder where you can identify, like write down where you want to save your stats, and the activate. Now let's look at the input file. The input file is very simple. It contains the name of the block, which you have provided in the model. Then we support 3 metrics, which is time in the block, buffer occupancy, and utilization. And the constraint, whether less than, greater than, less than, equal to, greater than, equal to, and so on. And provide a constraint value, which can be according to the model configurations, whether you want to calculate, whether you want to get all the stats, or whether you want to just calculate minimum, maximum, and mean for the block. So let's look at the output files. So in the normal operation, we can see we got this stats, and this contain, like this is the stat I captured for like first few packets, and this stat contain generated time. The packet came in, the block from where the packet originated, the packet ID, and the buffer occupancy at that time, how much the server block was filled up, and what is the capacity of the server block. Means right now it can hold around 20,000 packets at once, and how much time it is the particular request of packet stayed inside the block, and what was the utilization of the packet. So what we observed was the stats from the buffer occupancy is very much interesting. As you can see that initially in the normal operation, this buffer occupancy was around 3. Whereas when the model was under attack, we recorded the buffer size around 6, higher than what we observed in the normal operation. So as a number of requests suddenly got increased, or the from the hacker cluster, we see that the packets in the server started to fill up. So this is one way to identify these from the statistics. You can identify which of the algorithm is failing. Now, if you can see, this particular slide provide more insights. Means we talked about that in our constraint file, the input file was having the statistics as min, max, and minimum. So you can also identify, you can get the measured value, and the results can be also obtained whether the constraint value passed the calculated value or not. And you can verify the constraint. It also provides the design recommendation that your particular the threshold was around this much microseconds, and right now the service is extremely busy, so it cannot go below the threshold, and the time it provides. And the best part is you can identify all the virtual connections which are in the model. So as you build a more complex model, you might be using connection, you might not be using the wires to connect the blocks. So in VisualSim, you have the ability to just put the blocks and put the reference of the block and it can send the packet across the model. So using Inside Engine, you can also identify all the virtual connections which are present inside the block, inside the model, and understand, okay, was it correct according to the planned configuration. So all these things help us, to detect the overall system and network behavior, and by finding suitable algorithm as well, updating parameters and configurations, and finding the loopholes before the deployment. Uh, and this helps us analyze different scenarios and outcomes as well, which helps in making a better product. I hope you enjoy this video. If you have any questions, you can send your queries on info@mirablazedesign.com or check the website www.mirablazedesign.com. Thank you very much.